Hey there, everybody. Today we're joined by Puneet Saraswat, founder and CEO of Current.xyz, an engineering research firm building scalable business intelligence systems that create insight from data using AI and ML methodologies. They are some of the best in this space. Now, Puneet has a master's in applied geophysics, was a lead engineer at Frequency Protocol, where his work focused on developing privacy preserving blockchain architectures and decentralized data distribution. He also worked with Shell, Schlumberger, and developed certifications for MIT, of all places. Phenomenal. So tell us, Puneet. Well, actually, before we get into it, welcome.
Thank you. I'm happy to be here.
We're happy to have you. So tell us, what's the story behind Current?
So, Current is not just a random idea that popped up. It's something that has been in making from past more than a decade. My first paper on AI research came out in 2012, where I was trying to understand, can we model a human immune system in a computer? Like how it functions, right? Human immune system generally functions by identifying antibodies and preserving, and it has a memory. So next time you get attacked by the same pathogen, it does its job really well. And that opened up my brain around the future that might become, because 15 years ago, the technology was not there, like especially computations or graphic cards. They were very much in early stage. Even the research around AI was in early stage. But now, as I progressed throughout my career, I needed to know what are the things that needs to be known at my front to really start a completely like ground up AI companies. Some of the things that I involved in was like working with really massive amounts of data. When I use the word massive, like really think the massive scale. It's very hard for people to comprehend the scale of data sets in some of the operations which runs the world, like energy industry, or you're talking about agriculture, you're talking about weather forecasting. Some of those data sets are massive. Like it includes data from a lot of sensors, right? We have weather forecast sensors in a lot of places. We have satellites. We send a lot of missions on the field to collect data. Plus, we also produce data by ourselves, like experts within the field in respective fields. They use their knowledge, their experience to generate. For example, a geologist would understand the complete layout of a petroleum basin, like the rock type, the structures. So that descriptive information is also very valuable. So when I talk about massive scales, I talk about petabytes, and beyond that, that's something you cannot store in one place. How would you use that much amount of data? So the journey involved learning more about distributed systems, learning about high performance computing, also understanding a lot of interdependencies that are coming in the world of AI, which is nature inspired algorithms like genetic algorithms, swarm optimizations. So when this cumulatively combined together last year, around mid 2023, more than a year ago, I finally realized that I have all the pieces that I needed to solve. One of the biggest problem in our energy and resource exploration is we are not collecting more data anymore, or very limited, because so far we have complete data of all the major basins across the globe, be it from North Sea all the way to Brazilian basins to Gulf of Mexico, all the way to Gulf of Qatar. So all the data around these basins is there, all the information is there, and in real time, we are still collecting a lot of data as we speak. That made us believe back in 2020 when I was briefly working with Shell. And the question that was put in front of all the other AI scientists and engineers was, what is the future of energy and resource exploration? The answer was a future resource exploration will involve any subject matter expert or field experts to be completely immersed inside the data. By immerse, I mean like this, imagine this petabytes of data 1 or 2% team has to look into to find some more leads, to find possible opportunities that were overlooked before. That is only possible when so much amount of data is interconnected. And by connections, I don't mean that, oh yeah, they are stored in a specific cloud or they're stored in a silos or they, you have to really model the connections. And that's where Querent started, where I started experimenting with how can I do some neural network modeling to start setting up these connections between various data points. So one of the starting point was a lot of this data in energy and resource exploration is pure descriptive. Even the data that we acquire from field like sensory data, eventually we translate into some sort of description. Like oh, I see a trace, I see this signal, and the signal from here to here would mean that that signal passed through a basalt, or that signal passed through a gas pocket within the earth. So at the end of the day, even the sensory data get translated into descriptive, right? So Querent was an amalgamation of all these experiences together to kind of build a sort of high performance agents in the world. In the world of AI, these things will be called agents, right? Like AI agents and all. Basically, like this much amount of data, even if we put a team of 2 people or 3 people, it will be really difficult for them to process. So we have to involve some sort of neural architecture, which kind of mimic some of the patterns that we as humans use to make sense out of few things. For example, if I see, oh, I see a shale deposit in West Texas. Automatically, a geologist will think of all the history of that area from Jurassic all the way to present moment, and it will give them a lot of information. So we have to start modeling our systems in such a way that it kind of like mimics human cognitive abilities, and these kind of tools that you would be seeing quite more often now. If you follow Mark Lecon from Facebook's AI Meta chief, he posts a lot of the research from Meta where they are trying to convert thoughts into words, right? So that means like we are entering an age where we will interact with data more and not with the systems directly. And systems will be developed in such a way that they take most of the responsibility and you become the interpreter or the human input on the end. And that's where the whole vision of Querent came along.
Fascinating, honestly. That is absolutely fascinating. I could
This
probably
is
make
fascinating.
2 to 3 hours just trying to dissect what you just told me. But let's try to make it a bit. Let's try to communicate like the practical part of it. So, what is Current doing for these companies or for your current clients?
Right. So my first entry, because I'm building a system which can be generalized for a lot of use cases, because at the end of the day, it's just modeling, right? So you can model something for energy, you can model something for mineral resource, or you can model it for business operations in an e-commerce company, because they are also looking massive pile of data that they have been collecting and they collect every day. But my first entry is into solving the problem where the we personally believe, I have a strong opinion that the future is of data analyst. Everyone, just like we have a lot of software engineers right now, in the past we had a lot of data entry specialists when the web became a thing, when internet became a thing in late 90s to early 2000s, there were a lot of data entry jobs, right? Then came the customer service jobs. Now customer service is also automated by using these automated tools. So what I personally believe is the future mineral resource exploration or energy exploration, including not just renewables, but also fossils. Our demand for fossil is declining, but we need to be sustainable when we phase it out. And slowly we are starting to move into more uh, natural resources, renewable like geothermal, right? So in my vision was the jobs for a geologist, a geophysicist, or a petrophysicist will not disappear, but they will transform into more data analyst. So for that perspective, I've been building this, keeping purely energy focused. The idea is, for example, I'm a geologist in a company and my job is to explore Gulf of Mexico or Gulf of America. And the idea there is that I have experience working on a specific field in North Sea or in Brazilian basin, right? A lot of these geologists are pretty much plays a very specific role. It's just like permutation and combination of things needs to happen, or you need to find a gas pocket, or you need to find an oil pocket, right? So it's called transfer learning, right? So can I learn something somewhere else and be able to find things which are very similar to it across the globe? And this I'm saying very lightly, because if you understand the massive volumes of data that are at play at this, technically it's impossible. So much so that this project in Shell, we parked away for a while and I changed my course. I went into blockchain industry to really understand how the distributed system works. So that is important to learn. But now when we came back and now we have all this research coming out in a lot of AI fields, a lot of papers are coming out. So the distant reality, we thought that geologists and petrophysicists will be able to explore the world by sitting in their office and will have these new tools which are interacting with them. The tool itself isn't going to interact with them. It's not going to be traditional click, upload, download.
Right.
The system itself will evolve to mimic human interactions, right?
Right.
And my focus right now is to reach out to some of the clients in energy. For example, I'm presenting my work in France in upcoming conference called EAGE, European Association of Geoscientists and Engineers. Last year, there's another conference in Houston for American engineers. It's called Image, where I presented the similar ideas. So the goal right now is, can I provide this tool to these energy companies so that then can finally homogenize their data? And the idea is that this tool will act like a platform where we will continue to enhance it with better and better interfaces and stronger algorithms as we learn by ourselves. And so that their work can cut down from years and months to mere weeks and sometimes hours is what my immediate goal is.
Right. Wow. Wow. So, okay. So if I were to put into more like layman terms here, you're making data conversational in a lot of ways.
Conversational, experimentable, right? Can I interact? Conversation is one thing. Like we can create a large language model out of all the textual data out there and open up a chatbot, right? But that chatbot will not be giving you a more detailed understanding of things you're learning, because you can't, if a large language model you trained on all the data within your organization tells you that, hey, go to this market, there's a potential there, and you turn out that that was just a made up excuse, which we see a lot, we call hallucinations. So you also don't want to 100% rely on language models. You also want to integrate some developments in neural architectures. There's a lot of experiments on how we can pair large language models. There are also time series models, time series FM. Google has also released a lot of weather forecasting models, right? All these play into picture when you're doing energy operations. The idea is that, can we do prognostics with all this large amount of data before even stepping into the field? So that is reducing our carbon footprint, because it reduces the wasteful of resources. Plus, we are creating an avenue to start different kinds of tools that as a human species, we haven't thought yet. Like we were only thinking of this dashboard application. You click here, you click there, and then you get a report and you're done with it. All that thing can now be modeled as a neural architecture, and you can now like automate some of the work moving forward. So if that is not clear, you can ask further and I can clear it
Yeah,
up.
no, of course. Now let's try to. I'm trying to understand it myself, right? So how about let's use an example. What's an example of like a recent project that you've completed where you have turned these massive multi-petabyte beyond data sets into something not just
Right.
conversation?
One of the research topic, one of the research paper that we're going to present in France talks about source to sink matching, right? What is source to sink? This is mostly around carbon capture. And as we are entering more into the age of renewables and carbon offsetting our carbon footprint, right? One of the key challenges is that we have so much amount of data. Can we use it to identify places where we can dump the carbon down? These places could be some old oil wells, right, which are dysfunctional and not operational. You can use them again and you can start pumping the carbon down. Or it could be some abandoned mine or somewhere that carbon gets trapped and it does not never comes out in the environment again. So the research involved, I have a source which produces carbon, let's say a coal power plant, right? And that it's already producing so much of carbon emissions, and then all the waste that comes out of it is again carbon, right? So how can I, in a most optimized fashion, put that carbon into a sink where it never comes out, it traps again, and I don't want to create more carbon footprint doing so. You're talking about hauling tons and tons of coal, ash, and debris and putting it into an abandoned mine, which is not used anymore. So you also don't want to like, oh, the coal power plant is in India, but the location to put it is in America. You will waste a lot of carbon. You will create a lot of carbon footprint just to haul that much tonnage back to America. So you have to find something in the close proximity of it. So that will involve understanding few things. It will help you involve understanding who are the operators there, who will help you haul all this, right? What kind of terrain you are going through. So you involve a lot of map features, you involve data from satellites. What kind of geology it is? Is it a geology which will be affected by dumping the carbon there? You don't want to pollute that ecosystem, right, where you're sending it. So what we are doing is we are using these graphs like interconnected data points and across everything from from maps to old wells to reports on everything. And then we try to do something called link prediction. That, hey, I have this massive graph that I've created, which involves pretty much all the understanding of things I said, like operators, geology, reports, or any or the information of any abandoned wells or mines and etc. or geology. Now I have to predict what are the possible storage places for the carbon inside this data treasure that I have. So we have to do something called automated learning. It's called link prediction, in which we use some sort of a neural networks to connect various data points. And then we feed two things into it: carbon and store. And everywhere it can identify interconnected points that which are linked to, say, this carbon modeling. It can identify, oh yeah, this is a possible place where you can store the carbon, or this document talks about some sort of carbon offset in the data set that you're talking about. Because at the end of the day, the data will be selected by the expert. The expert will say, I want data for that region, so you don't need the whole world data. But even within that data, the expert, if they have to sit down and go through 1 million files, in our case, we use 1,500 reports, and that itself is a cumbersome task on a lot of human, you can't just sit down and read 1,500 reports in a matter of hours, I would say. So we built a system to be able to model these kind of use cases. So the research that we are presenting now is, hey, I have these reports around carbon capture. Let me identify all the possible resources, all the possible links between carbon storage and these resources, these data resources. So that will bring down the time to filter out valuable knowledge from 1,500 reports or 1 million reports to maybe 10 reports. Like now you have to just read these 10 of these, which possibly has some sort of connection around the carbon storage that you have been talking about. Is that a generic example enough?
That does help immensely in understanding
You
the value.
filter down. At the end of the day, we are just creating the neural networks and these LLMs are just big filters, right? It helps you identify the thing that you need to know right off the bat. The thing about LLMs is, oh yeah, you have a question. It has learned about pretty much everything that has been fed to it. So you already get the answer. That's why ChatGPT and all have made us more productive. And similarly, we need tools for other things like, as I mentioned, in energy operations, in resource exploration. You also need these kind of filters, these neural networks, to now filter down these massive volumes of data into more meaningful, right? Back in those days, the enterprise search is a good example. Enterprise search, if you have worked in any big enterprise, they almost use custom Google search or Bing search, right? But the enterprise data is not general specific data. It's very specific to their business, right? So the traditional search engines don't fit that narrative in enterprises. That's why a lot of these companies like Shell and other operators like ENI, they are trying to build these kind of technologies because they understand the value of filtering down to the point information that we need to know will save time, resources, and will actually make operations more efficient.
Right, right. It cuts down the time to
Yeah.
action,
It
essentially.
could another good example would be like in e-commerce business, right? People are buying stuff on your websites all the time, and then their location. You collect people they collect some information on you, like where you located, what's your location, what's your age, and pretty much that helps them create a psychological profile around the consumer, right? And then you have all these consumers scattered across the globe, and say you're trying to pinpoint, oh, I want to sell ACs now. I used to sell fans. I want to sell AC now. And I want to identify where is a possible demand for AC growing right now. You probably will have to go through ton and ton of material to figure it out, but having a centralized way to like model data and then you identify a AC cell, right? Where it's getting sold faster right now. So you'll always find out the places which used to be cold and now becoming hotter because of climate change. You will find more ACR being sold there. And that's one of the strategy like a lot of these e-commerce companies use to go and capture the market before anyone else realize, hey, like there's a potential market there. So that's
Exactly.
another good example of like filtering down all those information and then finding the link between different things.
Exactly. Exactly. I have a hand. Honestly, I have an infinite amount of questions.
Yeah, feel free. Yeah, it's like we are in a phase where ideas are infinite at this point, and we just have to pick
Exactly.
one
To
and go
take
with it.
action. Yeah, right. Exactly. You just have to take action. And in a lot of ways, the companies, and this is a question I wanted to ask you specifically that was coming up multiple times. These companies, enterprise companies like Shell or otherwise, do they already own the land or potentially own the land that they would like to do some carbon
I
sequestration?
remember there was this player, Anadarko Petroleum Corporation, which got sold to Occidental in 2019, 2018 timeframe. And they were doing quite an interesting use case around, like, the use case would be you go and acquire the assets first, right? And if your fancy model is just saying the probability of finding an oil well under that ground is say 90% or even 70%, let's say 60%, going down to the accuracy levels. So if I just go buy 10 pieces of land or lease it, like it works in oil and gas industry or enterprise, that works by go leasing it, right? They go ahead and government sends, if it's a public land, the government lease them out, right? If it's a private land, the owner lease them out. They don't buy the land, they just lease it before their competitor does. So if a 60% accuracy model is saying that there is 60% chance of finding a oil well, they will go get 10 pieces of land. And even if six of them turns out to be profitable, they have made billions by then, right? So that's where you see the power of these technologies, like just making these small decisions, which can eventually lead to bigger profits down the road. And that's where a lot of these enterprises are thinking, can we maximize our value by finding more of these hidden patterns in these massive volumes of data? Think of Gulf of Mexico. It's so huge, right? It's a water body. It's massive. We have explored quite a lot of it, but people are 100% sure there are still places in there which can be explored further. It's just that we might have overlooked them because, say, ExxonMobil is working on one use case, Shell is working on some other area. They never communicate with each other, right? So a lot of the information that they have and they have, it's not overlap. And now there is another platform that is coming up called OSDU, Open Subsurface Data Universe, which is kind of like a collaborative effort by all the energy companies. And they will put some of the public data, mostly like explored areas out there so that community can start developing tools like what we are doing. But yeah,
Interesting.
these are the use cases that are used in like critical decision-making process.
Right. Because essentially executives who have to make the business decision have to
Exactly.
understand what's the likelihood of actually profiting in a certain area, or what steps do they have to take in order to
Yeah,
create profit if they were to
exactly.
decide in direction.
Yeah, and it's like they want to identify like gas is becoming a thing now because we are going more electricity, so burning a lot of gas. So previously we used to just flare the gas out and just burn it off, but now it's you may want to go for the gas than the trapped oil underneath it. So all out of these is opening up new frontiers, and it's also gonna make all of these big companies more efficient. Like they don't have to spend too much amount of money into their own technologies, building their own data centers and everything, but they can thrive on these small community tools coming out, which are leveraging the power of these deep learning technologies to do some of these things.
Right. And I can imagine that these companies over the years have built up massive amounts of data sets that are still in a lot of ways untapped. So maybe before they were looking for oil, but now they're looking for natural gas. Well, the data does have that in there. You just have to make it possible to go out and explore.
Exactly. You
Wow.
just have to look, and sometimes comparative analysis itself is enough. Like, hey, I drilled this well in Brazil, and this is the geology of it. Like, oh, this rock, that rock, this rock, that rock. It's just a layer model, right? Can I find something similar across every data point I own across the globe? Is there something similar exist, similar geology exist? Then I can go look deeper inside of it. I can create teams. So like we found this point, this piece of data, which kind of like resembles that well that we have been talking about. You go explore that. We found another one. You go explore that, and so on and so forth. So it's just like also identifying leads itself is a big one because that cuts down, as I mentioned, a lot of these projects are span over years. And most of the time that goes in is just processing the data.
Right. Now, this is more of a personal curiosity question here. Now, I understand that there are limits to currently for how much data we can compute in even with supercomputers.
Right.
Now, I can imagine that some of these firms, enterprise level firms, are trying to use supercomputers or have to try to process some of this data, but even then, it might not be enough. So I'm wondering, A, are they using supercomputers to try to process some of these data sets? But then, moreover, B, is there a way to start to integrate cloud quantum computing to process some of this data?
Yeah, I mean, you don't need to go to quantum to process this data. You definitely have to come up with better architectures. So the cloud is involved. A lot of these companies have their private cloud environments partnered with AWS or Google or Microsoft or other cloud providers. Then a lot of these companies also have in-house clusters. And they have their own setup, which you use supercomputers. So they have their own in-house cloud environment, which is very private to them, which sometimes they use to run their own. Some of these logics that we run is like, for example, Current, the first product that we built, it can churn petabytes of data in hours, right? But it try to scale out a lot, right? So you will need access to resources so that it can scale out, process, and scale down, right? So that is already like we have been doing this for quite some time, but now what the thing that have changed now is the way we used to represent data, like the data modeling has evolved. In the world of these deep neural architectures or large language models, you can think of representing data more into vector spaces than into silos. And the thing about vector spaces is that you can compress them as much as possible. But they also offer you a lot of mathematical tools to develop algorithms. As I mentioned, link prediction, right? Like from this to this, is there a possibility of finding a carbon or storage within the data that I'm looking at? So it does involve a lot of high performance computing, as I said, and high performance computing is hungry for servers, right? But my philosophy, and I think the general philosophy when it comes to distributed computing is you build, you do not build to scale, you build to scale within a system first, and then you distribute it. You focus on one small system and you make sure that it is capable of using all the resources in their system perfectly. And then you use whatever techniques on the cloud or on the clusters to scale out your deployments and be able to process larger amount of data. As I mentioned, the one of the use case we did was had like 1500 reports, which was somewhere around 15 to 20 gigabytes. And we processed it under 30 minutes. That too on a simple computer, and we were able to build a model also without like having to go on the cloud. But I imagine the use cases that we will encounter in some of the energy companies will be petabytes. Like, hey, it's not just 1500 reports, it's 1.5 million reports. So if you're thinking about that scale, you have to think about cloud. You have to think about, are you going to buy your own systems and connect them together to create this cluster? You want to go and buy some super clusters from companies like IBM or Dell and these kind of providers.
Right.
But
Interesting.
most of these energy companies, they do have their set of like when I worked in energy for 10 years and I have used supercomputers for like almost my whole time while I was working there, because eventually some of these jobs, we call it, consumes time, right? And you want to just turn it on and leave it and you come back 5 days later and it's finished, something like that.
Right. Exactly. So then, I mean, we've covered a lot of ground so far. So then, what's the answer to the core question that brought us here today? What are the three key barriers preventing companies from maximizing the potential of AI tools and workflows?
Right. So one of the thing is like the data is very scattered. It's completely in silos. Either like you'll be surprised because a lot of these companies have been operational for hundreds of years. Like Shell was founded in like 1926 or something. Schlumberger I worked for was founded in 1926 by Schlumberger brothers. And the data that was acquired in all those years are still in the tape records. You'll be surprised. And they have to manage that and all. So now with a lot of initiatives like centralized like data repositories like OSDU, as I gave the example, a lot of these companies are now moving most of their data. It's the first thing is data preparation, right? And that when it comes to energy and the kind of operations that I'm going in, it's a massive challenge because you're talking about petabytes and petabytes of data, which sometimes can take forever to even upload. So most of this data might not even stay on the cloud, but its footprint or metadata, as we call it, will be on the cloud. Like, hey, where to find it? Oh yeah, I found this data point which kind of matches your query, but where do I find the actual file? Oh, the actual file is with Schlumberger in one of their tape drives. So we will not be able to move all the data on the cloud while the process will be like the OSDU is barely coming out. So it will take years for all of these energy operators. But what energy operators can do now is they can upload, they can start to focus on few things like fix your data repositories, start modeling data in such a way over to you so that we can build applications to directly work with those systems instead of, okay, Shell uses this, so I have to support this. Exxon uses this, or this energy operator uses this. So if there's so much heterogeneity around how the data is modeled and represented, if that needs to homogenize, right? And another thing is like open the data for AI and AI modeling is going to be like very like everyone is doing it, right? So having some realistic data sets to really model, like if I'm trying to do projects on carbon storage, right? So is there any good data sets that you have already worked on in some of the carbon storage projects that you can make it available for us to test and build our systems? So I believe like it's most of the challenges are mostly around how do you store and represent data in the current ecosystem to truly leverage a lot of these AI tools.
Understood. So then the quality of the data is
Quality, yeah, the quality really won't matter. The good thing about these deep learning technologies is that the noise eventually gets canceled out. If you are done a correct right job to model your neural networks and model your experiments, so a lot of the noise that comes inherent to data, for example, a file may have gibberish words which does not mean anything, but also have some meaningful words. If you think about large language model, they worked on the attention basis. One attention mechanism is how many times I saw that thing, right? And a word which is which adhere to linguistics, which is a correct semantic word, will be seen a lot many times by these models than some made up word ever did, right? So the advantage of these deep neural networks that you don't need to do a lot of data cleaning, but more around data preparations. The old traditional ETL pipelines are no more serving this purpose because we need to open up the faucet. And so it's CLT. Now you have like, you extract, load, and then transform. So yeah, I think around data preparations, making sure that data is accessible, like through some protocol. It could be internet protocol, it could be your localized protocol, but having a direct access to data so that we can suck that data into our systems and be able to run our modeling. The way most of these AI technologies, which on the large data like mine works, would be like they siphon in data, no cleaning required. You just directly go into it. And then you use some new of the algorithms that are coming in the space of AI, which automatically sometimes takes care of noise cancellation that we're talking about. So we don't have to think about quality of data per se, but the availability of data is more important at this.
understood. Understood. And what's one of the main issues I'm assuming with a lot of these older companies is that a lot of that data, there's so much of it, it's all over the place. It's not ready for actual ingestion and preparation for the
Exactly.
ETL
Exactly.
pipelines. So it's
Right.
about building those ETL pipelines.
Yeah, but it's like Saudi Aramco was able to build a language model because they always had their data into private servers, so it was easy for them. But in majority of the cases, the way like most of this valuable or confidential data that energy related or resource related is kind of managed by the policies of the governments, right? So which are different from different countries. So in the United States, for example, like the land is leased out to a company for a specific period. After that, that data becomes public, for example. For 20 years, that will be hidden and then it will be public. Or someone else can come and buy it because you tried, you didn't find all, maybe good luck next time. Some other one like, oh, we have some secret soup, we might be able to find something, so let's buy that data. So a lot of this data is openly sold in the market, but again, there was no homogenized way of putting data at one place, or at least accessing from the one place. It's more about accessibility than just storage.
Understood. Understood. Okay. So then if we were to take a step back, considering that companies need to prepare their data for extraction, for upload, so then you can actually start running these models and finding the opportunities. And you can communicate this, sounds
Right.
like, to the two companies. Like there is a genuine value add because there are millions, if not billions of dollars to be made. And
Exactly. And
essentially
save. There's a lot
investing.
of saving involved. The good thing about AI is it. I'm not sure how much money you will make in it, but the future will tell. But at least you can save a lot of money right now. That's the first step, right? You can cut down on you can identify, as I mentioned, these systems and platforms will not be the way it is. As I mentioned, then even the human interact with the systems will change. A lot of research going on, thoughts towards, right? It's very hard to comprehend that if there's no mouse and you're just interacting with a touch screen and you're doing a really massive project and all you have is a touch screen. So it's more about like how the human AI interactions also evolve with time. The first phase I believe in AI would be saving a lot of wasteful spending. That is what, because you don't need now very specialized, the definition of tools will change and is already changing right now as we speak. So yeah, it's definitely savings first, and of course the profits will come.
And then opportunities thereafter. So then this is going to be more of a business question, but considering everything that you've done, you're obviously a subject matter expert who can explain this to people and the value out of it in phases, not just in an immediacy. What would you say is the most pressing bottleneck for growing your business then?
I think it's about nailing down a business model. If you think about the early days of internet, well, nobody knew what it will become, and we are communicating on a video streaming platform, which nobody thought 30 years ago, right? So we are still like, we are in the beginning phases of how don't make one product company. I believe that we will be like someone invented a cursor in MIT team, build a tool called Cursor. What I build, I call it a calculator.
I
So
did.
think like that, right? Think about what small things you can invent which can do a massive change than building like a super massive large language model to solve all the problems. Because not everyone should build large language model. We need them, right? They're really useful because they compress all the data that has been fed to them. And not everyone can have that kind of money, millions of dollars to train one cycle of these models. But think about what thing you will invent. Like a cursor has been invented. Will you invent a calculator? Or will you invent something? Focus on building the correct business model. Like I'm inclined more towards a hybrid consulting and product-based business model where you license these products, build it in open source, like so that everyone learns and someone will be able to find some other thing other than cursor and calculator, right? And because this is a very specialized field, don't expect everyone to be able to understand it right away. So that's where you can harness a lot of consulting practices, right? Think of Deloitte model or BCG model, but now you're taking some AI tools with you to these companies and really helping them solve some challenges and saving them a lot of money. But also like proving your consulting, like setting up your consulting route if you so want to. So my personal opinion is keep finding new products and build a product-based ecosystem. Then, hey, I have this fancy chatbot. That's all I want.
Understood. So keep it open source, keep it open minded, solve one very specific problem, and then move forward from there and just understand the people that you're solving things for. Amazing. So we're at the 40-minute mark, went over
Oh,
by about 10,
already. My time clear.
but time flies when you're having fun, right?
Yeah.
So one last question. Because there are going to be other guests after you, what one thing would you like to share with the next guest of this podcast?
I think pour in as many ideas as possible. A lot of things that I said, like while talking to you, a lot of things clicked in my head while talking to you. So I think more pouring in ideas, because we can't possibly build everything on the planet when it comes to AI, right? It should give opportunities for even new innovators. And sometimes just hearing a random thing from a person who is doing it clicks to a lot of people. So just pour in as much idea as you have. Like I try to give as much information in limited time. I had more, but so because then it will help me to like really go and listen to the next speaker once you upload your podcast. So yeah, pour in your ideas, open your heart, see what kind of crazy innovations that can come out of it.
Understood. All right. I'll pass on the message. Okay.
This sounds good. Thank you, Jose. It was
Thank you, Puneet. It has been a wonderful, eye-opening conversation.
for sure. Thank you. Bye.